This is a preview to the course on multivariate analysis for data science. Now, data science is an emerging area in today's world. Okay? It has various applications, both in the academic and the professional fields. In fact, data science is applied in natural sciences, in biological sciences, in social sciences, in finance, in industries, in commerce, and in management, and various other fields. So this has become one of the aspects that we look at when we want to study any feature of in any one of these fields. So what is basically data science? Of course, data science relates to data. And in the modern world, with the advent of computers, modern computing facilities, etc., there is available a huge amount of data. So this data, in fact, whatever studies that we do, whatever experiments, whatever studies, whatever features that we want to look at, we collect data. Collection of data and storage of data. Huge amount of data, as I said, is possible because of the modern day computers. But then by itself, collection of or storing of data is useless if this data is not properly analyzed and make later use of. So that is where data science would come in. Now, when we look at the different features of a data, there are two directions that the data is collected in. One is the number of individuals or units involved. So we might have a large population and we have data on each member of this population. Okay? So for example, we are looking at the Indian context and we have data on 1.3 billion Indians. Okay? That is one feature. The other feature is that for each and every of these individuals or units, we have several aspects that we look at. So we look at different aspects of a given individual. And that is where the problem starts coming in. So let me share the screen with you and let me tell you what this multivariate analysis of data science is about. It's about looking at a large number of variables involved in a study. And let me give you an example for this. Look at these faces. Suppose we want to look at faces of different individuals. A face has many features. Okay, you can define a face by its nose, by its eyes, by its ears, by the shape, by the mouth, by the chin, by the hairs. Then you have the colors, like the color of the skin, the color of the hair, the color of the eyes, etc. You can look at the shapes of the different features like nose, mouth, chin, again, eyebrows, everything. So you have so many aspects of each individual that you are looking at. And that is where the problem comes in. So when we want to define a face, what exactly do we look at? We look at this vast amount of features that we have for each individual. And then again, we have a large number of individuals. Usually, the number of individuals doesn't create much of a problem. With the computing facilities that we have now, taking account of this large number of individuals is possible. It's not too difficult. But when you have large number of features, okay, like the features of a face, then we have a problem as to how to identify a face given only a few features. I can't look at all these features, so many features. Maybe there are 100, 200, 300 features of face. So that is where the problem comes in. And these features generally, in statistical terms, we call it the variables. So there are so many variables. It's a multi-variable problem. If it is a single variable, if I'm just looking at the eyes, for instance, not even the colors, etc., just the shape of the eyes, then it's easy to identify individuals or to categorize them. But when we have so many variables together that we want to look at, it becomes nearly impossible to bring out the salient features of the spaces. And then we have what is referred to as a multivariate problem. So what is multivariate analysis about? It is about the simultaneous study of several variables, where we are looking at all these variables together rather than independent. Let me give you a very simple example. When we look at heights of individuals, we can study the heights by themselves. And then again, somebody else is looking at the same individuals and looking at their weights. And he can do a study on weights as well. But somebody decides that, okay, heights and weights of individuals are related. And if I want to study them, then I have to simultaneously study the two variables. So for each individual, I have to take his height and weight and then make a simultaneous study. Because very often we see that the greater the height is, the larger the weight is also. Okay, so there is a relationship generally between heights and weights. And that is a feature that we want, that is an information, or that is something that we would be interested to capture. And therefore, we look at the simultaneous study of several variables. It takes into account the interdependence between different variables. So if you look at them independently, we cannot account for the interdependence between the variables. But as I said before, when you study simultaneously several variables, there can be at times too many of them, and it becomes unruly. It becomes very difficult to study them together. So we need these multivariate techniques to solve these problems. Three major areas of interest are clustering and classification. So when we are looking at the faces, some faces are similar to others. Some faces are completely different to others. Okay, so can we group the faces according to their similarity? So some of the faces, we put them together because within the group, they are similar. Okay, they are not exactly the same, but they have features which are close to each other. Whereas their features are completely different from those of another group. We call it the clustering problem. And the classification basically is, if new people come in, a new person comes in, which group do I put this person in? So it's more or less a grouping of individual problems. So how do you group similar individuals according to their features? Mind you, if I have one feature, if I'm looking just at the color of the eye, it's very simple to do. Just some has blue eyes, some brown, some black, so just segregate it. But when we have more than one variable, it becomes complicated. And as nowadays we are looking at big data, in big data, the major problem is having several variables. Okay, so in that case, of course, we would need to find methods to group these individuals, cluster these individuals, and classify them according to their similarity. This is one major area of interest and one major concern that we have with huge amount of data. The other is dimension reduction. So in dimension reduction, we have a huge number of variables, as I said. Can we bring this down to a few dimensions, maybe 3, 4, 5, 10 dimensions instead of 500 or 600 dimensions or features, so that it's easy to comprehend, it's easy to analyze, and easy to interpret later on. Okay? So rather than looking at all these, can I summarize this into a small number of dimensions? That is referred to as a dimension reduction problem. And that actually helps us to minimize or to optimally minimize this huge data set into a smaller data set, so that we can basically have a clearer understanding of the features of the data. So these two techniques, clustering and classification and dimension reduction, are multivariate techniques which does not almost arise in univariate cases. Dimension reduction is only when we have large dimensions, so it doesn't happen in single variables. Clustering is very simple or trivial in single variables. So clustering again is an area of interest in multivariate studies. The third is a cause-effect relationship. Here we have a large number of variables, okay? And some of the variables may be causing the other variables. And we want to find out this interdependence as to which causes which. If we can do that, then we probably need to look at only the cause variables because we'll know the effect variables given the cause variables. This way also the dimension can be reduced. This way also the features can be understood better, the relationship between the variables. So this is another area that has come from bivariate data to multivariate and then to this cause-effect relationships in general for multivariate analysis. Okay. So these are the three topics that primarily we'll be covering in this course on multivariate analysis for data science. There would be other topics, but the focus would primarily be on clustering and classification and dimension reduction, and to an extent on cause-effect relationships. Thank you.